Lecture 2, Statistical Inference 1, Random Sampling, Statistics and Point Estimation. Now, Lecture 2 is the first of two lectures on the foundations of statistical inference. And in this first part, we're going to be looking at random sampling, statistics and point estimation. So there are 6 parts to this lecture. As usual, I'll begin by defining the learning outcomes. We will then look at the concept of statistical inference. So what is statistical inference about? And we'll cover some basic definitions concerning random sampling, data, and the concept of a statistic itself, what that actually means. There are 3 main objectives to statistical inference that I'll define in the second part of the lecture. And the remainder of the lecture this week will focus on the first of those objectives. We'll consider objectives 2 and 3 in lecture 3. But this lecture will focus the remainder of it on the first objective of inference, and that is parameter estimation. So in part 3 of the lecture, I'll define the key elements of parameter estimation. In part 4, I will discuss methods that we can use for parameter estimation. And then in part 5, I'm going to look at how we can evaluate different methods of estimation. And in the final part of the lecture, I will, as usual, provide a summary. So in terms of learning outcomes, following this lecture, you should be able to understand the key statistical ideas and definitions that support analysis of data. So those underlying principles. You should be able to deduce the concept of a statistic as a random variable that has a sampling distribution, and you should be able to define what these concepts mean. You should be able to calculate simple metrics or statistics that can summarize data descriptively. And then moving on to estimation, you should be able to form an estimator, which is simply a rule of function that allows us to obtain some estimate of a population parameter that we're interested in. Following the lecture, you will be able to distinguish different methods for parameter estimation, and specifically, you'll be able to calculate estimates using the method of moments and the maximum likelihood estimator. And finally, you'll be able to derive criteria to evaluate those estimators based on the property of their sampling distributions, and those properties concern both finite sample and so-called large sample or asymptotic properties.